Welcome to the physics class, BSc, third semester, paper name Geometrical and Physical Optics, Electricity 1 and Basic Electronics. In this paper, third unit, Theory of Dielectrics and Moving Coil Galvanometer, session 15, we learnt about measurement of high resistance by leakage method using ballistic galvanometer and applications of the ballistic galvanometer BG. That first we seen how to measurement high resistance by leakage method using ballistic galvanometer. This circuit diagram is as shown. So this circuit diagram which contains ballistic galvanometer, resistance, 2 plug keys and capacitance and applied EMF for battery. So BG is the ballistic galvanometer, R means resistance, C is the capacitance, K1 and K2 are the plug keys and the B is battery. So here now we see the theory. This resistance of the resistor R is measured connected through the circuit. R be the resistance measured to the circuit. Here BG is an ballistic galvanometer and C is the condenser of a known capacity, B is a battery and K1 is the plug key and K2 is a meter key. K2 is a meter key which is used to charge and discharge the condenser through the ballistic galvanometer. So how it can be worked? Now we see keep K1 is open by pressing K2. K1 is open by pressing K2 on K2 to N direction, charging the capacitor or the condenser to a potential V0, charging the capacitor to an V0. Next connect to the K2 to M direction and note through the ballistic galvanometer. Let θ1 again be charged through the condenser and θ1 again charged through the condenser. Open K2 and close K1. Open K2 and close K1. Open K2 and close K1. Allow the condenser to leak through the unknown high resistance to the R for a T seconds. Unknown high resistance will be leaking. After this, open K1 and connect K2. After this, open K1 and connect K2 to the M direction. Again measure through the ballistic galvanometer. Let it to be in θ2. Now let we know thing about that. V0 is an original potential of the condenser and VT be the potential at the end of the T seconds. Q is the charge on the condenser at any instant of time. C is the capacity of the condenser. Now we charge through the R at the time when the potential C is V. We knowing about I is equals to rate of change of charge, that is dq by dt. Q is we knowing about Q is equal to C into V. Substituting this one, here C is constant, we taking right side minus C into dV by dt. Here negative sign because I reduces with Q with charge, current reduces with charge. I is equals to V by R. Ohm's law we knowing about that. Substituting these two equations, I is equals to V by R, we will get minus C into dV by dt. Rearrange this equation, dt will comes to the numerator, dt by RC minus dV by V. This integration will be this above equation, integrating from the limit 0 to t, that is time dt by RC. V will be changes from V0 to Vt, V0 to Vt, then into dV by V. T here d 1 by RC will be constant. Integration of dt is d, which is equals to limit from 0 to t. We will get t by RC left hand side, which is equals to 1 by V is the log V and substituting upper limit minus lower limit Vt minus V naught minus of Vt by V naught here there. Therefore, we will get finally log of V naught by Vt. After that we will find out the resistance. R is equal to T dividing by C into log to the base E V naught dividing by Vt. If C is Q naught is the initial charge of the condenser and Qt is the after time t seconds, then V naught by Vt is equal to Q naught by Qt, which is also equals to theta 1 dividing by theta 2. Final formula for the unknown high resistance, we will get R is equals to T dividing by 2.303 into C into log to the base 10 into Q naught dividing by Qt, which is equals to 1 by this term we will get 0.4343 into T dividing by C into log to the base 10 Q naught by Qt changes to theta 1 to theta 2. This is the high resistance finding the ballistic galvanometer. Now we see what are the applications of the moving coil ballistic galvanometer. It is used for measurement of quantity of the charge, used to measure total charge passed through the coil over a short duration. Determination of the capacitance helps in the measuring the capacitance of the capacitor by charging it through the galvanometer. Measurement of high resistance used with a capacitor and stopwatch to determine the high resistance by leakage method. Comparison of EMFs can compare electromotive forces of two cells using potentiometric setup. Measurement of magnetic field strength utilized in the conjunction with a such coils to measure magnetic field strength are the changes in a magnetic flux. Determination of self and mutual inductance. It helps in calculating the self-inductance of a coil or mutual inductance between two coils using induced charge measurement. Calibration of the ballistic galvanometer used for calibrating other galvanometers by comparing known charges. Study of damping and the oscillations, useful in studying damping factors and logarithmic decrement in oscillatory systems. Thank you for watching.